Hi there everyone, I'm going to take you through your results and then drawing graphs from these and then working out the glucose concentrations there in your Coke and Gatorade and the sucrose samples. So what I've set up here is an Excel spreadsheet. I think that that's a really good program to use. It's not very intuitive though, so I'll try and explain to you what I'm doing as I go through. I don't assume that everyone is as familiar with Excel as I am. So I've put in here some headings so that we're able to track what's going on a bit better. We've got our sample concentration, so these are our glucose standards that you prepared. So the concentrations here, 0, 1, 2, 3, 4, and 6 millimolar. It's really important that you've only got numbers in these cells here. Okay, if we put mm in then for millimolar, then it's not going to treat it as a number, and so it's not going to graph it correctly. So really important here, we've just got our numbers in these values. You've then got your A1 values, and I'm just going to make up numbers all the way through this. So I don't want to see the same graphs that I've got here because your numbers should be different. So your A1 values are in there, and then you've got your A2 values, so this is at the end of the assay, and then what we want to calculate here, and you can either calculate this yourself, or the good thing with Excel is we can get it to do the calculation for us. So I'm going to say equals, so the A2 value, which is that one, minus the A1 value, which is that cell there. Then if I hit enter, so in that first cell we can see they're the same number. So A2 minus the A1 is 0. But then what I can do is drag that down, and it's going to do that same calculation in each of those cells there. So for example, if I click on this cell, we can see up here it's D7 minus C7. So there's our D7 cell minus C7. It's done that calculation for us. So then what we can do is to plot this in a graph. So I'm going to insert a chart, and the one that I want here is this XY scatter. Might just zoom in a bit. So we've actually got 3 series on there. We don't want all 3 series, so it's going to tell us that series 1 is going straight along here. So this will be our A1 values. We don't want the A2 values, we only want the A2 minus the A1. So if we come into here, so series 1 is going to be our A1 values. We don't want it. We don't want the series 2. And series 3 we've got the X values are B2 to B7, and the Y values E2 to E7. So that's our column E is our A2 minus the A1 values. So let's call this our glucose standards. Okay. Now, that grey colour, we can probably improve that a bit. So if I right click on there, we can format that data series. And so from here we can then choose what we want it to look like. So at this stage we put a marker. It's given us a grey one. Let's choose something a bit better than that. This nice blue colour here. So that's the marker, that's the border of it. The fill will give the same colour, that same blue. And what we can see there is we've got data points here at 0, 1, 2, 3, 4, and 6 millimolar. So we can see there's nothing there at 5. If you've entered some text into here, and I'll show you that, if that was a 2 millimolar, you can see now what that's done is it's treated these just 1, 2, 3, 4, 5, 6. So we don't have anything here at 0, but we do have something here at 5. So we don't want to do that. I'm just going to undo. Okay, we can click on this graph, go into design, we can add a chart element, and we can add some axes labels here. So primary horizontal, so this will be our glucose concentration in millimolar. We can add another chart, axis title here, the primary vertical. So this is absorbance. And there are no units for absorbance, so we don't have to worry about the units there. Okay, the next thing we're going to do is to add a trend line. So this one gives us a straight line there. We've got a few different options, but the one that we want here is linear. We want to set the intercept to equal 0. So that way it goes through the origin here, 0 and 0 on the x and y axis. We want to display the equation on the chart, and we can also display this r squared value. I'm just going to move it over here, it's a bit easier to see. Okay, so there's our formula for a straight line. So we've got, on the x-axis here, we've got concentration. On the y-axis, we've got absorbance. And then we've got here this formula, y equals 0.063x. So now what we're going to do is look at our Coke and Gatorade concentrations. I did start putting some data in here. So Coke and Gatorade, again, just label those so we can see what's going on. At this stage, we don't know the sample concentration for Coke and Gatorade. We know the absorbance values, and again, I'm just going to make some numbers up here. So those are totally made up. Yours I would expect to be different. We've still got that same formula. I can keep dragging that down, and it's going to give us some numbers here. So now we've got our Coke and Gatorade samples. We know the A2 minus the A1. We can work out now the concentration. So if Y, this is going to be our Y value here, equals 0.063x. X is our concentration. So X is going to equal Y, which is our A2 minus A1, divided by this gradient, 0.063. So your number is going to be different. That's going to give us there our glucose concentration for Coke. We can do the same here for the Gatorade. So this is our E9 value, the A2 minus the A1 for Gatorade, divided by the gradient. Those numbers, we don't need all those significant figures. They're not that accurate. So if we just convert that to a number, 2 decimal places there is fine. So we want to add these values onto our chart as well. I think that legend there, we might be able to move that. Let's see if I can. Design chart element. So if we want to have a legend, we can have it on the right. I think that's going to be a better place for it. I'll just move that back into our graph there. Okay, so we want to add Coke and Gatorade. So if we come back here and we go to select data, so we're going to add another series. So we'll call this one Coke. The series X value, X is the concentration, which we've just worked out is that cell there. And the Y value is the A2 minus the A1. I'll pause there for a sec. So these blue points here, these, because I've made these up, these are quite close to that line of best fit, that trend line. But they don't necessarily have to be on that line there. However, for the Coke and Gatorade, because we've worked out their concentration based on the slope of that line, then these must fit on that line. Okay, for this data point here, it's not selecting. It's okay, I'll keep going. we'll add the Gatorade in there as well. So again, select data. We're going to add in another one. So this will be called Gatorade. The X value, X is concentration, is going to be that cell. And the Y value is the absorbance, is going to be that cell there. And again, we can change the appearance of these. If you want to make them look a different color, different shape for the marker, you're more than welcome to do that. The next one then is for our sucrose standards that we made up. So I did start to enter some data in here as well. So we've got 12 of these samples. Okay, so 4 of them at pH 2.5, 4 of them at pH 3, and 4 of them at pH 5, and then 4 different temperatures at each pH value. So again, I'm just going to make up some numbers here. Totally made up. Okay, don't use those because they are wrong. So now we've got 12 more samples. We want to have each of these being on that line of best fit as well. So we know the A2 minus the A1 for each of these. That has kept doing that calculation all the way down there. And again, we want to work out the concentration for each of these. This should work. If I drag this one down, it's going to continue to do this calculation for us. So in each cell there, it's doing E10, which is this cell, our A2 minus the A1 value, divided by the slope, which in this case here, 0.063. So we can now add each of these data points onto the graph. So if we go into select data, we're going to add, so this will be sucrose, and the X values are the concentration, so from there to there. Select all of those. And the Y values are from there to there. There we go. So now we've got a dozen data points, these green points here. These are from our sucrose solutions. So what we want to do now is to work out the concentration of glucose in these drinks, not in millimolar, but in grams per 100 milliliters. So this is what's given to you in the information on like a can of Coke or can of Gatorade. So we're going to take this millimolar information, and the samples that you were given, these had previously been diluted 1 in 100. So we're going to have to factor in that dilution as well. So for Coke, then the millimolar concentration is that cell there, and I'm going to drag this down, and it should do the same thing for Gatorade. So this is what we worked out from our glucose standards there, and our A2 minus the A1 for our Coke and Gatorade. So let's start by accounting for that dilution factor. So if we take that number and we multiply that by 100, it's going to give us, and again we just want these as numbers, this is going to give us our millimolar of what would be in a can of Coke or a can of Gatorade. So that's millimolar. Let's change that into molar, which is the same as moles per litre. So everything from here on in will be on the undiluted values. Okay, so equals that divided by 1,000. So we're converting from millimolar to molar I'm just going to take all of these cells here, make them all numbers. So that's that. Sorry, it should be over 1,000. Let's go that way. Okay, so that's that's moles per litre now, moles per litre. We can use the molar mass. So we're dealing with glucose, and glucose is grams per mole is 180. It's close enough. So what we're going to do is moles per litre times grams per mole, then that's going to give us grams per litre. Okay, so that is that value there, the moles per litre multiplied by grams per mole. So this is how many grams there would be in a litre of Coke, and then same process, give us how many grams of glucose there would be in a litre of Gatorade. And then lastly, if that's how many grams there are in a litre, then we want to work out how many grams there are in 100 millilitres, which is 1/10 of a litre. So there's going to be 1/10 as many grams of glucose. Okay, so you can then report these numbers here. You can repeat that process for the sucrose at each of the samples there. I want you to work out if these numbers differ from what's reported for Coke and Gatorade. If you're finding that there's more glucose present, that could be from the hydrolysis of sucrose. If that is the case, what conditions are causing that hydrolysis of sucrose? Is it temperature? Is it the pH? Are there any other factors that might be causing the hydrolysis of sucrose to give you a higher than expected concentration of glucose in your Coke and Gatorade? So you can repeat those steps there for your sucrose samples. You don't have to show those in your report, but you can discuss why your values here might be different to what you would expect for Coke and Gatorade.